Hello viewers, this is Mithul here. This is module 6. We will be covering about the data query language commands. So let's just start. In this module, we will be covering about the select statement, related clauses or statements. So let's just go through one by one. Top n will return the top n number of records from the result set. Where clause will help us filtering the records from using the where clause condition. Group by will help us the summarizing the group by specific column list that you would be providing. Having clause will provide us the filtered records based on the group by condition or maybe the aggregate column under which under the having clause that you provide. Then the order by clause will provide us the ordered records from the result set. Either it will be like ascending or descending order, and based on the order by clause column list. Then comes the offset fetch. Now returns offset fetch basically is used for the ordered records, and after that you want to skip number of records and then you want to fetch number of records. That is how it works. Okay, so say like here in this case, like the records after skipping offset number, meaning like how many number of records you want to skip, and then how many number of records you want to fetch from the result set, and that result set should be the ordered result set. Okay, so order by clause is must for that to be used, and fetch keyword is an optional. Maybe how many number of records you want to fetch out of the result set, that is an optional one. Then comes the select into statement. Now returns the new result set based on the selected result set schema. Say like whatever may be the data types in your source table or whatever, right? The table. So it will fetch the appropriate data types for each of the columns from that source and prepare the target schema and target table even, and load the data together within that. Okay, so that is how select into works. Then the union or union or all. Now union returns the unique records. Just remember that always, like union will return you the unique records from the result set, whereas the union all will include the duplicates in the result set. Okay, so that's the main significant difference between them. Then the common table expression. Common table expressions are basically creating the work table in the TempDB. Okay, so that is like an intermediate result set, but it's not been given like a appropriate name like you give it in the temporary tables. Okay, so consider say like it's a work table. Okay, then prefer the when small result set. When you are targeting very small set of records, right, to be fetched, so in that case you would go for the city. Then it is also used in the case when you want to do the recursive some calculation, right? You want to perform some calculation, you want to traverse through, say like you want to generate random dates, right? And maybe like you want to generate calendar dates, or maybe you want to just create the hierarchy, or you want to go up to the nested level of the hierarchy of, say like employee to manager, right? Those kind of things that can be done. And user friendly construct separating query is required. Okay, then the last one is the subquery that we will be covering in this module, which will be the result from an inner query, or we can say it's a subquery, which is contained by the outer query, or say like a select statement. Okay, so that is the subquery. So now let's just go and see all this in the action. All right, so first of all we'll be covering about the all or distinct. Okay, now all is used in which case? See, when we want to fetch number of records from a particular table, right, we just write the statement called select star from so and so table. Let's say we selected this this database. Okay, AdventureWorks data warehouse 2019 is what we are using now. Let's say we selected the dim product as a table. Okay, now here when we are not sure of how many columns being there, right, what you will write is select star from dim product table. Okay, so that will give us the particular product records. So this is what you will get in the results. Now, in case you want to specify a particular keyword instead of in addition to the star, then also you can mention like select all star one and same, like the earlier one, like select star or select all star, both are identically same. Okay, no difference in the result set. Here the difference is in the case of select distinct. When you say distinct means what? Say here how many records we saw, that we saw about like 606 records, right? Now in this case we want to fetch a particular column, a unique set, unique list of values, right, in the result set we want. So in that case we would use the keyword called distinct. So distinct would give us the unique list of colors, okay, from the table called dim product. So let us just run and see that. So ideally there are 606 records in the table overall, but out of those how many distinct colors which are available in the table, that is what it has brought to us in this result set. Okay, so this is what the select all or distinct option that we could use with the select statement. Second comes the top n, which we just elaborated in the PPT, right, and the presentation slide. So now what is top n? And it can be used with the percent and with ties option. Okay, so what is basically the syntax of this top n percent, or it can be used with the ties keyword. Okay, so let us just understand what is percent option. Percent option is used in the case when you want to return the number of records in the say like you have 100 records, for example. Say now out of 100 records you want to get 25% records in the result set. So how would you write it? You would just write it like select top 25% star from dim product. So the total number of records, say like 100 records will be there. So out of 100 records, it would bring up only the top 25% or say top 25 records into the result set. Okay, so that is how the use of the percent keyword or the option is here. Now in case when you do not want to mention the percent, instead you just want to mention say number of records you want to bring up in the result set. So then you can mention the number of records in the like a integer value kind of thing, or maybe you could use an expression instead of that. Any of the option that you could pick. So let us just pick the option called top 10, which is like a number that we are providing to this parameter, and saying like we want to fetch only the top 10 records from the table called dim product. Okay, so let us just run. Yeah, so see here it is bringing up the product key. I mean this is the identity column. Okay, so or say like a primary key column. So it has brought the top 10 records, meaning from the beginning of the table till the 10th record. Okay, so that is how it will be used. Then in case of the static value, you want to bring up some expression or say like some calculated or say like maybe some intermediate value. You want to store it in a variable, and then that variable value is what you want to use as a parameter to this top, and then you can use it like this. Declare the variable with a particular number that you want in the number of record set. You will select the 7. Say maybe you want the 7 record out of the, or say like a 7% is what you want to bring up in the result set. So you will write say 7, and say in the bracket you will put in like the expression variable, and then say keyword called percent, meaning it will be treated as a 7%, not as a 7 value, but as a 7%. So say like 606, then percentage of 606, like out of 100%, 7% of the 606 will be written in the result set, like that. So let us just run. Okay, so 43 would be the approximate value, roundabout as a 7% out of the 606 records. Then comes the option as with ties. Now what is with ties? When with ties are used, option is when two or more rows that tie up for last place in the limited result set. Okay, means like you have the two records, like it is in the same sequence, or say like it has the similar number of values in the row entirety. So in that case, you would like to return all of those ties wherever there is a tie of records. You want to return only those records, or say like a sequential records. Then in those case, you would use the keyword called with ties. So say like from the top, maybe from the beginning of the table, you want to fetch say like a 7 record with a tie. So it will bring up the records, the initial 7 records it will bring up in the result set, and the order will happen based on the product alternate key. So we are ordering the records based on the product alternate key here. So let us just see in the result. Okay, so here it has brought total 7 number of records. Now see, like the initial 2 records it has brought here, and after that there are 5 records it has brought from the random pick. But because it has random pick, because there is some of the values which are identical in the row entirely, which made it bring up in the result set. So that is what the with ties option. Either it could be the beginning, or say you could use the bottom, or say maybe you can use like a top and say like a descending order maybe. Okay, so in that case it would bring up the reverse result from the bottom. Okay, so now from the bottom it has brought the records, considering say like this one will be the first record, then the up to seventh record, like that. So that is an option here. Now next one will be the where clause. Okay, now what is where clause and between and like option? Now where clause, when will we use, like say like you have got the 100 records for example. Now out of 100 records you have a condition, say you want to fetch out of those 100 records, you want to fetch only the yearly income people who has their yearly income as 40,000 for example. Okay, so what we will do is we will put in like a clause where select star from this table, say like AdventureWorks DW 2019 DPO, the deemed customer as a table, and say like a where clause. This is the column on which we want to apply the filter, meaning like we want to filter the record set, or say like the results coming from the source. So we will put in like the condition called yearly income equal to 40,000. So only 40,000 income people, or say customers, will be returned in the result set. Let us run and see. Okay, so here yeah, so yearly income is what you see, all of them will have the same income. Okay, so that is what you can just list it down here. Now it is like a equal to is an operator. Okay, now it's a comparison operator. Basically we will cover it up in the subsequent module, but before that, like you just consider it as if like a condition, or say like a equality check maybe, or equality condition here in the where clause. Okay, now the second type of where clause could be written is, say like you want to provide a range, say like starting with this range to this range, right? You want to fetch that many number of records. So how can you do that? You can put in like a between keyword. Okay, between keyword will give you the starting of the range, and keyword will give you the end range of that. Okay, so the starting will be 10,000, whereas the ending will be 40,000. So like we want to fetch all the customers whose yearly income starts between the range called 10,000 to the 40,000. Okay, so let us just see how it brings it up. All right, so here we see yearly income is like 30,000, 20,000, 40,000, 10,000 maybe, right? So all sort of range, all sort of income comes under this range between and keyword. Okay, now if you do not want to use say like between and keyword, how you could use the similar functionality, you can achieve it using the comparison operator called greater than or equal to. So let's say here we are saying like the yearly income greater than or equal to, means greater than or equal to 10,000 is what we are starting up the range with, and we are saying like the end range is less than or equal to 40,000. So anything between 10,000, starting from 10,000 till the 40,000 range of yearly income, we want all of them in the result set. So this will be the same result that you ran in the previous query. Okay. Yeah. See. So it will also have the same number of records in the result set. Then say like now we want to use the keyword called like. Now we do not know exactly or say like maybe we want to fetch only the customers who has their income equal to 40,000, but in addition to that you want to give some precise condition. Say out of those number of records, out of those customers also, you want to check the customers who has the commute distance. Okay. Now let us just see that first of all, like what is the commute distance of them in the query. So you will understand what is commute distance here for each of these customers. Okay. So say like we have got 2747 records, right? Now the commute distance we will see, right? What is the commute distance? He is saying us like this customer is coming up from how much distance, how far he has come to a place, right? So the commute distance basically. Okay, so how far he is residing basically. So that is what the commute distance. So 5 to 10 miles he is saying, or maybe 1 to 2 miles, or maybe different ranges are there, right? So in this kind of range kind of results, now I just want to fetch only a particular range customers only out of the 40,000 income customer. I want to fetch only the customers who has their say like customer distance, right? So there okay, let's say like we want to fetch only the 10 miles 5 to 10 miles customers. Okay, now how will we fetch is the initial range starts with 5. Okay, so let's say like the range starts basically with 5 here. So and the end range will be 10 here. So if we want to fetch and all of the records starting with this range and ending with this range, right? So we can fetch using the like keyword. Like keyword has an option. There are two expression. There are two special characters basically used for that. You can say. So how it will be used is, sorry. So first of all, if you want to fetch any number of records, any number of digits, or any number of characters after or beginning with, say like you want to fetch any number of characters, okay, starting with say like we have the range called 5 to 10 miles. This is how the range for us is. Okay, I'll write it here so you will understand what here it is. Now this is how the record it says, right, as per the result here, 5 to 10 miles. Now that is what we want to fetch. Now out of this 5 to 10 range we want to mention here. So we do not want to, or maybe say like we want to make it relax, maybe like let's say instead of 5 it could be 1 or 2 or maybe 3 or 5 or 4, right? So starting range it could be anything, but the ending range we want to limit with say like a 10 as a mile. But the keyword we are not mentioning here because miles are remaining same everywhere. If you see, right, in each of this commute distance you will find the common keyword is miles, right? So we do not want to mention the keyword called miles. Instead we want to say like anything after 10 is written, maybe the any sort of expression is there, any sort of character is there, right? So it should fetch everything. Just starting can be anything, and in the middle of that the end range should be with the hyphen, and then 10 should be the digit, and then anything could be there afterwards. So that is how, if you want to fetch the number of records, you will like write the expression like this, the like expression. So let's just run and see. So see, all of the 5 to 10 miles range customers only we have found, and their income also we want to see. Then all the 40,000 yearly income customers we have fetched. Now out of those, all the 5 to 10 miles distance customers we have found in the result set. Now we want to say we want to fetch something else. Maybe we'll pick up some other range. Okay, so you will understand the other type of expression, how it can be written. Now say we want to fetch 1 to 2 miles maybe. Okay, 1 to 2 miles customers. How will I write it? So like I know the starting range of it. Okay, so I will express I will mention it like 1 hyphen 2 is what I know for sure that the end range is, but miles keyword I do not want to write, say. Okay, so that will be anything. So basically here in a short, if I would like to say, then say like a percentage represents any number of characters. Okay, from the string, from the column value. Okay, so that will be the search string, you can say. Okay, the other thing could be used as if like there is an underscore that you could use. Okay, for a specific character, from the column value. Okay, now if you want to fetch say like any specific character, so how can you do that is using this. Let's say we do not know whether it is 2 or anything specific, but we are sure that it is in a single digit only. Okay, we are very much sure that the start range of the miles is 1, but the end range, it could be starting from 1 to 9 maybe, right? It's in the single digits. For that reason, so we will mention like 1 underscore. So consider say like 1 placeholder or say like 1 character. So that is what it will fetch, and then say anything after that. Anything after that you want to fetch into the result set. So that is how you will write the this is how you will write the select the like expression. Okay, now you see all of this is bringing up the 1 to 2 miles. If it was even any other range within this customer commute distance, then it could have find that range. Maybe 1 to 9 it could be there, 1 to 5 it could be there, right? Anything if it is there, then you could mention it like this using the underscore. Now say like maybe you just want to give it anything after hyphen. Maybe you want to give a large range, anything after that, right? Starting with 1 but ending could be anything. Then also it will fetch the range because it has only one range falling in the commute distance called 1 to 2 miles. So the same number of record, ideally like 719 what we received currently. So the same number of record we should be receiving, right? That is what we have received now, because considering that there is no other range or say like there is no other commute distance in the entire number of records. Okay, for that reason. So this is how you can write the like expression to find and fetch the particular number of characters from the column. Okay, column value. So this is all about the where clause that we wanted to cover. Then comes the group by clause. What is group by clause? Group by clause is basically if you want to return, say like you want to return a number of products. Okay, you want to return number of product categories. So let's just comment all of this and then just want to return. See, I'm considering the same database, AdventureWorks Data Warehouse 2019 as a source. So the fact internet sales is what I'm using, joining with the product table, then the product subcategory, dim product category. On all of these tables we joined up using their primary keys and foreign key returns. Okay, so this is the foreign key in the fact table and the primary key of the product table to the product key. Then comes the product subcategory, the primary key to this product subcategory. Then comes the product category table and it has the primary key called product category key. The product subcategory will have the foreign key to that. Likewise, the product subcategory will have the the product table will have the foreign key for the product subcategory. So we are mapping to prior table here in the respective order. And in the group by clause, we are writing here a particular column. Why do we write this here as a column? We want to group that. We want to group the result set based on a particular column. Let's say we want to group the result based on a particular category name, so that we are writing the column name here in the group by clause. So what it will do, it will return all of the result set with a distinct number of distinct product categories in the result. Okay, so let's just see in the result. So see, in a whole table entirely, or as a like a whole result, if you just want to see how many records are there, so just see. Okay, I'll show you that how many records in at a whole are there, right? This many records are there in the table. 60,398 is the total count of rows that we have in this table. Now out of 60,000, it has fetched how many records? Only 3 records, right? So it has fetched only the 3 records in the result for us. Why? Because it is considering it as a group records. So there are 2 ways. See, if you want to bring the result, the unique records in the result set, there are 2 ways. One way you could use is the distinct keyword, but distinct will check each and every column. Distinct will consider each and every column of your say like the entire table, or say like in a query, all of those columns will be considered a unique values, and it will fetch the unique value from the entire list of columns. Whereas in the case of group by, whatever column that you put into the group by clause, it will be group by based on that particular column only. Okay, say like I want to group it by product category name. For that reason, I put it like the product category name. Now next say maybe I wanted to give it say like a subcategory maybe. Okay, so how can I write it? Product subcategory, English product subcategory name, and then say the same column name you will put into the group by clause. Okay, so we'll write it here, and now what we will get? Likewise, we will find the category wise, product category wise, we will find each of the subcategories listing, because we grouped them, right? We group first it by product category, then the child category to that one is the product subcategory. Okay, see, so for each of this English product category name called accessories, it has got the this many subcategories. Okay, so say like bike racks, then the bottles and cages, cleaners, fenders, right? All of this kind of a subcategory it has found. Now let's say we want to go further down to the one more down to the level. Okay, we want to fetch all the product names belonging to that particular subcategory. How can we fetch that? P dot English product name, that we will put in the select list. Use the same keyword, same column here in the where group by clause, and then run the same query and see it will fetch all the product names together with that. So see how many categories were there? Only 3 categories, but then by the number of products, it has increased the number of records in the result set. Earlier it was 3, then it became 6 or 7, or say like maybe 10, right? So, and then it has increased from based on the product. So it is drilling down to that particular level. Say like started with the product category, then it reached to the subcategory, then within that subcategory how many products are there, so it has fetched all these products. Say like, just understand, the accessory is a category. Now it has got the subcategory called helmets. Now within the helmets, how many different sort of helmets are there? How many different sort of helmets is black, blue, red, all right? All these are 3 different kind of products, which are the different kind of products under the subcategory called helmets. Likewise, in the tires and tubes, you can see, right, how many items are there under that. HL mountain tire, HL road tire, mountain tire, low level, right? High level, medium level, right? All this kind of a different range and different size that it has given in the name of the product to differentiate it with the each of the product. Okay. So this is how you group them by a particular column. Now, this was about the columns that you would just like to see, or say you want to drill it down up to that level. So you started up with the category, you wanted to go up to subcategory, then you wanted to go up to this product level, then you gave it like a grouping here. But now, say like along with this column name, say like with a respective product name, I want to know like how many number of records are there. Okay. So how can we check that? We can use the count. How many total records? How many total records are there based on that? Okay. So based on this given condition, based on the given criteria, we will check the count function. This is the count function that you could use. You can just mention like count star or count one, whichever you use, one and same. Okay. There is no precise column that you may need to put in, but one will be considered as like the primary key column as a first. Okay. So for that reason we use it like that, and just run, then see how many number of records are there. So see, it has given us the respective with the product category, subcategory, and for this kind of product, how many total records are there for this particular product itself. Right? So how many times the product has been sold is what we can check based on this count of rows. Okay. So this is the kind of drill down information you can fetch out of this group by clause. Second option. Now say like we fetch the number of records, how many products was sold for a particular category or subcategory, right? After that we want to check like what was the minimum sale for a particular product. Okay. So that also you could find using the mean option. Mean function will fetch the minimum sale for a particular product. What was the particular product minimum sale, right? So that if you want to fetch, you can use this way. So see the minimum sale for say like the particular bikes, road bikes, and it has got the English product name. For this particular bike, the number of times the product was sold is 75, and the minimum sale value for that one was $699 in dollars. Okay. So that is how the drill down information you can get. Now you want to fetch the max excuse me. Now you want to fetch the maximum value. So same way, max function will be used. Max function will fetch the maximum value of that. Then say you want to fetch the average sale of the particular product, right? So starting and the lower, like the mean and max, the average value, whatever you say, right? Like the mean value you can say maybe in the mathematical terms then. So or you could use the sum of the sale, right? The particular product, how many what was the total sale, right? If you want to fetch the sum of the sale, or say like a total sale for a particular product for a particular timeline or whatever, right? So timeline we did not consider here, just maybe if you just want to fetch only the based on the product, you want to fetch all these criteria, then you can just write in the say in the case just remember one thing. In the case when you are applying the aggregate function, see all these are functions that I have mentioned here, right? All these functions are called the aggregate functions that we will learn further into the detail. But for now, just say understand as if like an aggregate function. In combination of the group by only we usually use them. Okay. In the case whenever, see if you do not have any single column in the result set, then you do not need any group by. Okay. But say like you have at least one column in the select statement. In that case, you may need to or you have to use this group by clause. Okay. Understand that. So if you do not have any of these columns, maybe like all three columns, you may not need even this group by clause at all. Okay. So this is how it can be directly run, and it will return you the expected result. Okay, so the total number of rows, the minimum sale, the entire list of product, it has brought the aggregated or say like a summary level. At a summary level, what is the count of rows, the total number of rows, what is the minimum sale of the entire level, from the entire table, what is the maximum sale for a particular category or say like the entire row wise, right? Then the average of that and then the sum of the sales. That is how it has fetched. But say like we want to drill it down to a particular level, then we would include one by one all these details. See, you want to fetch only the say like just in case you want to see like the category wise, you want to check all this detail, right? So how will you do that? You will okay, you just need the comma here. Okay, so you just want the category wise sale. Okay, you just want the result by category wise sale. What was the particular category specific sale and the in the particular timeline. So it will give us the 3 records with a respective clothing, how many times, how many number of records, say like how many transactions happened for a particular time frame. Maybe we are not considering, but say like for the entire table, right? How many records are there, or say how many transactions are there for clothing, how many times the clothing say sold, right? So that is 9101. Then the bikes, then the accessories. Likewise, the minimum sales, max sales, average sales, and the total sales for a particular category. Likewise, if you want to check further down, like how am I finding that much sale for a particular category? What were the product, the subcategories under that particular category which were sold this much, right? If you want to check that, then you will add the group by one more column to that and then see once again like this. So it will give you the drill down information further down to that level. At the subcategory level, you will find the details. So for each of these subcategory, you can order them, order the result in a particular thing. Okay, you can just say like order by with the same number of columns as you mention it here in the ascending order. Yeah, so just say execute. Now you may see, right, all these accessories. Now you see the subcategories, and for the each of the subcategories, how many times each of the subcategory was sold is the number here. Okay, then the bikes, then the clothing, all this. Then comes the particular product. So for product wise, how it was sold, right? All of that you can check it in the entire list. And just this. Okay, so this is how it is returning the entire result of the products, right? So basically this is what the group by clause is. All right, now let us just move on with the having clause. What is having clause and how and why we use it? Now let's say we understood group by clause here. Let's say we understood like the product category, we understood grouping, the drilling down up to a subcategory level and then go up to the product level sale. How much sale was done, right? But then you would like to see, say like for a particular range, like a sum or say like sale you want to check. How can you do that? You can use it using the having clause, right? So how can you do this? Using the having clause. So in the having clause, you may use this particular aggregate function and say for a particular column, say like a sales amount. In the where clause we understood, right? We can use the filter called yearly income, but that is like a particular row level filter if you want to apply. But here this is a group by filter. Okay, here it is a group level filter. Just understand the difference between these two. Whenever you want a column level filtering, then you apply the where clause. Whenever you need a group level filtering, whenever you need a group level shortlisting of the results, right, from the entire result set, then record set, then this is how you will apply. It could be used with the group by column, or it could be used with the sum, or say like an aggregate function. Okay, so whichever. Say like if you want to give it for a particular product category, then you may write the product category name. Okay, and give it, say like whatever. We will first see like whatever records that we may get in the result, and according to that we will add up that condition. Okay, let us just run first thing. So having clause. So see here we are finding bikes and accessories. What it has done is it has checked like whether all of this both these categories has the sales amount greater than or equal to 4 lakh, not the 40,000, my bad, maybe it is for 4 lakh in the sale. Okay, so here it is 4 lakh, greater than 4 lakh, whatever is there, right? Now let's say I just want to limit it by if I just say maybe up to, or say I will say up to less than. Okay, I'll just give it a reverse condition. Maybe I will say less than equal to 7 lakh maybe. Okay, so in that case less than or equal to 7, or say 7 lakh 1,000 maybe. Okay, so that we can fill this this one, right? So 7 lakh 1,000 is what we want to fetch. So now only one category we will fetch in the result set. Okay, is there sum of sales? Okay, let us just run. Oh, I see. Because the clothing also is like below this range, right? So that the clothing is coming up. So we want to say like we want to limit the result set between a particular range. In that case, maybe let us just do it this way. Say like having sum of amount less than or equal to say like 7,000, 7 lakh 1,000, and you want to say like the greater than condition, right? For the same thing you want to give it greater than or equal to what is that, 339, right? So instead of that 340,000 and sum. Okay, so if you give it like this, you may find only one record in the result set, because this is like a group level filtering. So here whatever you see, right, the accessories is having 7 lakh sum of sales, whereas the clothing is 3 lakh 39,772. So we want to do is we want to go above the 3 lakh 40,000 and up to 7 lakh 1,000. Okay, so here we are giving 3 lakh 40,000 and then 7 lakh 1,000 in the range, and then you just run this execute, right? So we found these accessories as sum of sale as accessories in the result. Okay, now instead, like say you did not want to mention say like the AND range, but you wanted to limit it by the category instead directly. You might remember, right? Say like what was the category name that you want to result. uh, uh, Maybe I'll give it something less than the range. Okay, okay, I'll give it something like less than okay, I'll give it like this. Okay, I will give it like this 3 lakh 40,000, or maybe say like 7 lakh even. So in the case of 7 lakh, less than 7 lakh, how many records we are finding? 1,000. We are finding 2 records, right? Yeah. So we are finding 2 records. But say like I just wanted to list only the clothing in the result set. if I was knowing well in advance, maybe like if I know like I out of this two result set, I want to get only the clothing in the result set. So how can you filter that is using this English product name, which is in the group by clause. See, one of them is the aggregated column to using which you are filtering, and then you are filtering using the group by column as well. So two of the ways you can do the filtering here in the having clause, but the same could not be achieved in the case of where clause. In the where clause, you cannot use the filtering using the aggregate function. One thing. Second thing, you can do the second function, which is like the particular column level, but that too will not be the group level column. Okay, that will be row level filtering. Clear? So just remember this difference between these two, and then you will find only one record in the result. Okay? This is the clothing that you retrieve. Even though you gave it like a more range, even though you give it like a 1,000 range, still we have filtered it using this group level filtering using the English product category name. Now, order by clause. Now, all of this that we knew that like we how to filter the records and all of this, but then still we may need the result being in the order. Let's say we want to give it for reporting purpose, we want to give it the query for say like a reporting solution, we want to give it in Excel, maybe in some reporting tool, maybe Power BI, SSRS, or any sort of tool, Tableau, maybe any open tool. But all of these queries, if you do the sorting by default in the query, that will lessen your load onto the front end layer. Okay, so to achieve such thing, there is a built-in keyword or say like a clause provided by the SQL Server is order by. Now order by comes in a two option. Order by comes in the ascending order and comes in the descending order. Now ascending order is like A to Z, like 1 to 9 or 1 to 100, right? Like that, the ascending order, and then the descending order is the reverse order, which is like Z to A, or it could be 100 to 1, like that it comes. Okay, so here we just simply are using the same old query that we just used in the previous blocks. I'm just for the example, I'm just giving it like ascending or descending keyword only, nothing different in the query than this order by keyword, and then put in the column order by. Okay, order by column name, whichever column on which you want to do the sorting is, this is how you do the sorting. Say like accessories and bikes. Just see the difference without any ordering. Okay, how it brings up the result. See, bikes is coming first, whereas accessories coming second. Now your manager say like, sorry, we do not want it in this order, we want it to be in the right order. So how can you do it? You will go and add this order by clause using the ascending order. Now say like, even though maybe there are couple of more categories or maybe number of more records into the result, and you wanted to return the result based on the maximum of the sales. Right now, let's say just we sorted it by ascending order here. Okay, let's just order it by ascending order based on the name you wanted to sort. So in that case, we sorted it by English product name, product category name. But say like you need for the reporting purpose, you want to sort them by the sales, right? Instead of this column. I mean, you wanted to sort them by these columns instead of product name. Okay. So how can you do that? You can do the sorting by sum of sales. How can you do this? Order by is just use this and then say descending order. Okay, or instead you could directly use the column. See, there are two ways. One way you could use the as is column, or else in the order by, it automatically understands, SQL Server understands that this column is going to be aggregated and returned in the result with a alias name or say like a new column name called sum of sales. So that also you could use. We will use it both the ways, so you will understand. Okay, so first of all we will use it with the keyword as is. Say like sum of f of sales amount, right? We'll do the sorting by descending order. Now the max sales amount will come in the top, and the least sales or say the lowest sales amount will go in the bottom. Okay, That is how it will come. Right? So say like the sum of sale, highest one is coming top, and then the second one comes the least one. Okay. Now if we wanted to do the sorting by, instead of using the sum of this keyword, he wanted to do it by sum of sales. You may say like, how come this will work? Because it is internal structure of the SQL Server, how it processes the query. According to that, it has it performs the calculation, it performs the compute, and it performs the processing and everything. After that, it has fetched the number of it has prepared the result set in the memory, and out of that result set it will have a column name now given as sum of sales, so that it will now easily understand that, yeah, I have a column called sum of sales. This is what the user expects me to order by the descending order. So that is how it will fetch the record in the descending order. Okay, so now it will be one and same, no difference, just the pattern of usage. Okay, so easy, and remember, you don't have to write this much expression and write the aggregate function and all the column. Instead, you could just use the alias instead. Okay, so this is the order by. Now instead of this, one more type. You, instead of writing this, some of them maybe used to write the numbering, which is not a good practice, but I'm just giving you for a sake, in case somebody writes in this way and they are used to writing this way, the ordering. So you should not feel that what this is and how this is achieved, right? So consider, say 1 is like the first column, 2 will be like the second column, 3 will be like the third column, right, and so on, up to n number of columns in the select list. So each of the columns in the select list are treated as 1, 2, 3 and so on, like that. Okay. So if somebody writes like that, order by 1, 2, 3 and so on, it may not precisely tell you, or the person who, maybe if this is a complex query, right, then from the complex query you might never understand, like by the sequence of the number, that which column it is. Maybe like 70, 80 columns may be there in your select query. Then how will you identify like which column is what, right? So to make it easily identifiable, we should always use the best practice to use a respective column instead of using the sequence number. But this is what I'm just showing you, like the ways of writing the query. Some of the people use it that way as well. Okay, so like I wanted to use which column? 1, 2, 3, 4, 5, 6. The sixth column I wanted to sort it by descending order, right? So let's say directly we'll write here the sixth column. I'll say descending. So it will do the same way, descending order. Right? It does the sorting that way. So this all are the various ways people use that. Maybe some people use case statements also, that we will understand afterwards in this session only. But so case statements also can be written. The various ways the queries are written nowadays, but this is just the basic that we are going through. So just stay focused onto this one for now. Okay, now let us move on to the offset and fetch. Now what is offset and fetch? Offset must be used with an order by clause. Okay, otherwise like it may throw the exception. Now if you want to use the offset, that is a mandatory, because we want to use the feature, right? So we want to use the offset keyword. So in that case, the fetch keyword is an optional one. Now how to use this offset and fetch? Offset and fetch can be used in a combination of first or next, and the other keyword is row or rows, whichever is the applicable one for your usage sake. So let us just see an example how to use it. Say like we are choosing a company category, okay, like a product category called accessories. Now for a particular accessories, we want to list down a sales for a particular product, or say like for that entire product category we want to list down all the products with their sales amount. Okay, now what we are doing here is we are just ordering the sales amount. We are basically ordering the products by the sales amount in the descending order. Now as we order them in a descending manner, what will happen is we may see number of records in the highest sales amount will be on the top and then the lowest will be on the bottom. So let us just see them in the result set. Okay, now as we see, like there are 22 products under the category called accessories. Now what we are seeing here is that highest sales amount is in the top, whereas the lowest one is in the bottom. Now out of 22 records, let's say we just want to list down only the 10 records, or say like only 10 top 10 only we want to list down. With the rest of them we just want to exclude. So how can we do that? Let us just see here. Okay, see, there are number of ways, but how to use this feature is what I am explaining you. If you say like you just want to list down only the top 10, then there is only a option here, right? We could use the top and then 10. Okay, it will just straightforward will return you the 10 records from the top. Okay, so there won't be a challenge for that. But see here, if there is a case in which you want to fetch after skipping 10 record, let's say somebody asks you like, I do not want the first 6 record, but I just want the top 7th record. Okay, let's say top 7th, or maybe the record after 7, whatever there may be, right? So if that is the kind of expectation, or that is the kind of requirement, in that case you might have to use this feature, use this option called offset and fetch. Now how to introduce that one is like use this offset keyword right after the order by statement or order by clause. After we mention like order by sales amount descending, then we say like offset and then give the number of rows that you want to skip from the top or from whatever be the sequence, because like here we are as ordering them in the descending order. So initially we want to skip, say like a 6 record we want to skip. Offset means skip. Okay, like just skip those records from the result and then pick the one which I will select from fetch using fetch. Okay, so fetch first one means after skipping 6 record, the first one will be what? 7th record, right? So that is what we wanted in the result. So it will give you in the result. So let us just see that in action. See, this is the 7th record from the top. Okay, so we skipped the initial 6 record, even we skipped the records after 7th record, meaning only one record we wanted. Maybe more than one records if you would need in the result set, you can mention it as per your need. Here instead of say like 1, you may ask say for maybe like 4 records possibly, right? So you may get the 7 to 10 record, right? That way if you want in the result, then you can use like this 4, and here it will be rows, right? 4 rows, because it's not a singular, right? More than one row. So we will use it like this and then just run this. Sorry, my mistake. Okay, we'll just say execute. So see, 4 records we have got. So initial 6 record it has skipped and rest of the 4 records it has written. So out of 10. Now let's say instead of using the first, you wanted to use the next one and say no difference. Only like next 4 records means the next means what? The initial 6 records were the previous, but then the next will be the next 4 records. Okay, one and same, no difference. Same number of records you may see in the result set. Okay, then here like the row and rows, like the singular and the plural kind of thing. I mean like the single row is there, then just keep it single, or else if there is more than one row, then say like a rows here. Okay, that's the only change. That is the main purpose of this offset and fetch. Understood? Okay, now let us move on to the union and union all. Now union and union all we just understood from the presentation earlier, that union will always give you the distinct record, or say like a unique record without any duplicates. Now in the case of union all will give you the records very fast, but it may include the duplicate records in the result set. Okay, so just be like selective in the case when you want to bring up the results in the output, that whenever there is least significance of bringing the any sort of data, then use the union all. It doesn't matter whenever you just want to just combine these sets and you want to result, then use it blindly union all. But whenever you are very precisely sure that like I just want the selective or say like a unique record only I want in the output, in that case you would use the union only. Okay, so let us just see the difference in the two, and then you will understand like how to use and which one to use. Okay, so first of all we will use the union all, which will bring up all the includes or ignores the duplicate records in the result set. So let us just see how it is returning it. We have taken only two of the columns. Okay, I like just willingly I wanted to show you that difference in here. Otherwise you may have more than one or maybe more than two records or more than two columns in the result set. Okay, here we are just one more thing important to understand is, in the case of union or union all, your type of columns should be consistent throughout all the union all combination. Okay, now each of these queries may have the select column here, right? That is what each of the columns should have the similar type. It may not have like say here it is like a varchar kind of data. See, like the employee, the English product name is the varchar data. But say here I cannot use like an integer kind of column as a first column, because the consistency of the column list should be same. The consistency of the data type should be same. Then and then only you can do the union all or union operation. Okay, so that thing you need to keep it in mind, that both of this or any of this union all queries, you need to have all the queries representing the same number of columns, same number of type should be there. Okay, then only you can join the union two tables or any tables using that. It will append the result set in the bottom. It may not show you in the form of like a column after combining it. In case if you want to do that, then in that case you might use the joining. Okay, so you can use the join table, say like one table to the other, you can do the join and then represent the column you want it to be there in the output columns instead of being there in the row. Okay, so yeah, that's how the difference is. Now let us come back here and just run to see that how this union all works. Okay, now as you see, like 51,297 rows that we retrieved. Now seeing to this many rows, it may not give us any idea or understanding, right? See, for one record, I mean say for one particular English product name and for sales amount, it may not give you the right information. If you just want to say you want to just bring up the summary, say like you just want to bring the summary like how many products and how many unique products that we sold and what were the prices to them, right? If suppose say that is what you are looking at. Now in that case it may not show you the right results. So to do that, what we may need to do is we may need to use the unique as an option. Okay, now see like out of 51,000, how much less number of records that you see after you apply just the union keyword, removing the all from the keyword. Instead of union all, if we just change it with the union and see the difference in the result. Okay, out of 51,000, how many records are written? See, 138 records only. So this is how the difference here is. Now what it basically does is like it is just considering both this column to bring up the unique result set out of it. It's not repetitively bringing up the result, which is the case in the case of union all. You may find all of the records coming up in the result set, whereas here it may bring up only the unique records. Meaning for a particular product, if the same price has been listed, then for the same product, the same price will never get listed in the output. Okay, so that is how this union keyword or say union operator works. Okay, it's like a set kind of thing, so it may work that way. Now, okay, so I hope like I made it clear here. Okay, so union and union all is clear. Now let us move on to the select into. Now this is a very interesting thing, like a select into. Now select into is basically appearing as if like creating a temporary table. If you are familiar with already with this syntax or the construct, then you may say like it is already an existing some there are some existing sources from which we just have to pull the data and create a temporary set. Okay, now if that is the kind of requirement, in that case you may use, or maybe if you have if you aren't sure like what will be my target table structure, right? What kind of data may come up from the source. So in that case, or maybe if there is a ad hoc requirement which may have come to you, in which like you do not have any data structure with you, like what kind of metadata it would be, I mean like the data types of each of the column, maybe like say like 1000, maybe 800 number of columns are there. You do not have the precise data type information. How will you do that? Then you will just straight away pull it from the source as is, load it into the table, and then start to consume it afterwards. Okay, or maybe then define it based on that, or maybe do some data profiling and then you want to use it or understand it, right? Whichever way, I mean, you want to use it then. So basically I wanted to show you two benefit or two advantage of this selecting to thing. How we can use it, like the one way of using it is I suppose say if there is a select statement. Okay, now I am using the AdventureWorks data warehouse like 2019 here, say like the product category table I'm using. What I want to do is I want to pull the product category key 1 and 2 from the source. Now what is that result? Let us just see first in from the table, and then we'll understand after that. Let us see what are the two records. See, these two are the records. What are the categories here? Bikes and the components. These two are the categories. Now, out of this category, what we want to achieve here is we want to create another table of the similar structure. How this dim product category table is, along with the data that we want to do, that we will do afterwards. But suppose say we just want to create the similar kind of table, how the dim product category table is. Now dim product category may have this many columns, 5 columns, and each of the column may have different data types as per the content type, right? So without having the create table statement, right? Create table statement, if we don't want to write, or we just want to directly run it, then how can we do this? Like we will just say like select, then add as many columns you want it to be there in the new table that you want it to be created. Okay, let's say maybe there may be 1000 fields, there may be 1000 columns in dim product category, but say out of those 1000 columns only you needed maybe 5-10 columns for your analysis purpose, or maybe for your further down process purpose. So in that case, what you may do is you can add as many columns as you need to be created in the new table. Okay, so select that many columns in the select list, put the keyword called into, give it a precise name, maybe whichever the name may be. You want it to be there in the schema, then you can put it in a schema. If you want it to be in a temporary table, you can put it like a hash table, right? The hash table like a temp table. That way also you can do, you can create like a global temp table, or you could create like a physical table, whichever way. I am just using it here for the sake to is like I am putting it like a physical table. I'm just creating a physical table. Okay, you may use like temporary table with table variable, whichever way you want, as we already learned. So you know now like how to create the table, right? And then you can put in that table name here. Now say we will give it some name. Okay, I am giving it a name called temp underscore dim product category. What will happen? I will have the from clause representing the particular table, having the where clause with a filter. All these are there. Now what I want to do, I just want to mimic the same structure. I do not want to pull the data from that. There are two possibilities. One possibility, you just need the data along with the table structure. And there is one requirement in which you do not want to load the data, but you just want the table schema be created. Okay. So in that case, how can you achieve it? You can achieve it using this way. You can say like select top 0. Top 0 means what? It may not bring up any data from the output. It will just mimic the same structure from the source to the target with a new name that you have given it in the into part of it. Okay. So that will just create the table structure here. Let us just see. Okay. All right. So it has not inserted any record and just created the table structure. Now, if you want to see like whether the table is created or not, let us just see in the running the query. So I'm just running the query, table is created. See the magic. Okay. We did not write the create table statement and still the table is created with the help of this simple statement. Select into statement. Okay. So this is the benefit. This is the advantage of using the select into. It can be used in a data warehousing. It can be used in a ETL. It can be used in a reporting. Any kind of requirements you may have dynamically, you may need for some analysis or data profiling purpose anywhere. But this is very significant option that you definitely need to understand and use it. Okay, wisely. Now, as you see that the schema is created, but say like now after the creation of the schema, if I have to insert the record into it, then how can I do it? That we will cover up into the DML commands that we will be covering in the subsequent module. But for now, if you do not want to go ahead with the way, I just shown you this example just so you know that how it can be created. So now let me just say drop it. Okay, for now, so that we can load the data along with the schema SL. Now, second way is in which like we are directly loading the data along with creation of the table structure. Okay, here there is no top statement or top keyword here. Okay, and directly we are loading everything. Here it was top 0. Top 0 means what? Nothing. It may not load anything from the source. It will just load the schema from the target source to the target. Okay, but here in our case we are not using top keyword here. So what may happen is it will load all this data from this based on this criteria. It will load the data from the source to the target with the given structure. However be the source table structure, the same kind of structure it will create and then load the data into this table for product category 1 and product category 2. How will it do? Let us just see. Okay, 2 rows affected means 2 rows are inserted into the target. Now let us run the select statement to see like whether there is any record or what. Yes, you see there are 2 records now. Okay, so this is the benefit or advantage or usage basically how we can use the select into statement. Okay, now let us move on to the CTE or say like some people may know it very well with the with statement, or maybe some people say like a common table expression. Some people say it like a CTE. It's like a materialized view or and a different kind of name people are using it to identify or to understand it. Okay, but for our simplicity, just understand as if like common table expression we are learning. Now there are usages, different kind of usages in which CTE can be used. Now first can be derived from a single DQL, data query language, or DML statement. It can be derived from a single DQL, data query language, or it can be derived from a DML, meaning it can be used with select statement or it can be used with insert, update, or delete statement. For that reason, this is how the DQL and DML is written. DML represents insert, update, and delete, whereas DQL represents the select statement only. Okay, so all 4 sort of statements can be used using the common table expression. Okay, Second point, can be used in a views. Now see, in a view, you, as you know, right, like how views are created. Maybe we are yet to cover up that part, but I'm just giving you an idea like how views can be generated. Views will always have a select statement most likely. Okay, so in that case you may not have the order by statement, and couple other rules applies, but for now just say understand, like in case you want to create a view, then CTE would be the first choice you can pick. If there are multiple tables, there is a tricky logic within that, right? That logic you can put in using the select statement, using some case statements or whatever, but eventually you may find it in the view. Okay, so that is the advantage. Third type is CTE. CTE can include reference to itself, meaning it can be recursively called. One CTE can give a call to the same CTE itself. Means you want to achieve some recursive functionality, then you can achieve it using recursive CTE. How it can be achieved? It is used, or it can be achieved using the max recursion option. There is a built-in feature of SQL Server that provides you the max recursion option to recurse and start it. I mean, that recursion range is like within the 0 to 32767 is the range for that, for the recursion. Okay, in the infinite loop it may continue. Otherwise, if you do not mention this range, it may continue to loop it infinite times, which we may not need in any case, right? If we are using the while loop, or if we are using some other sort of loop, then we may have to stop that at certain condition. Otherwise it may continue to loop. It may never come out of that loop, and you may not find the result what you are expecting out of it, right? So to limit that result, there is a defined range. Here is like 0 to 32767 in the option clause. Okay, for whether it be select or insert, update, delete statement, right? Now let us just understand with the example. I'm just creating a random employee table, and maybe for now I'm just using the employee table. Consider, say, like there are two columns relationship, like the employee and the manager relationship within the same table, like a self-joined kind of condition. So let us just populate this table first, and then understand it. Constraints you already learned, and if you do not remember or recollect, then please watch out my previous videos in which I have already covered the constraints. So each of these constraints, like the primary key and the foreign key constraints, I have explained it in great detail. You can understand from there. Now see, like the table, how it is created. The table will be created, then you insert the records into it. Okay, so all of this part I'm just running it. Okay, now SPC, like there are 6 records inserted into a table. Now what we want to achieve, what we want to see is, we want to see like without using the max recursion option. There are two ways. Without using the max recursion option, you can use it, use the CTEs, means common table expression, and you can use it with max recursion option. It depends on the number of records being written. Always remember how many records that you are going to return out of that CTE or common table expression. It depends on that only, always. All right. So whenever there is a recursive functionality, meaning like call to the same CTE, if you have given, then only. Otherwise, you can use CTEs as if like a normal statement, select statement that you can use within that. Not an issue. Okay. I'm just explaining it with the usage of recursion purpose. Okay, so like we have employee table in which we have the ID, employee name, and then the manager ID column. Okay, where we want to list the first record, meaning like the top level of the company, meaning like CEO or CTO person, right? He may not have any manager above him, right? For that reason, he may not be having any manager. So we are always listing them in the first. Okay. Now rest of the people will always have some manager, like a report to whom they will be reporting, right? So in that case, we will write the union all. Okay. And union all, what we will do, select employee ID, employee name, employee manager ID from the employee table. Then you do the join with the same city employee manager list. The same city I am mentioning here in the join. Put the join on manager ID equals to the employee ID. Okay. So the first one is the employee. So employee, you join the employee's manager ID with the employee ID, because both of them are eventually same. Manager ID or employee ID, both are eventually an employee of the company only. But one or the other way, just excluding the top level of person, you may have rest of the people reporting to someone. Okay. So for that reason, like the employee ID is representing the employee ID as well as it is representing the manager ID. Okay. Now we will just see to that list and the result, and then you will understand what I'm talking about. See, here I'm saying like the employee ID 1 is his name is AAA, and he doesn't have any manager ID, means he doesn't have any manager above him. Okay. Whereas the 7th number employee ID, his name is DDD, whereas his manager is manager's ID is 1. 1 is what? This one, employee ID 1. That is what means, like the DDD's manager is AAA. Okay, the employee name. Okay, the same way like the third number employee. Third number employee has the manager ID who is reporting to, 3 is reporting to 5th number employee, which is CCC. Okay, now CCC is reporting to whom? CCC is reporting to 7 number, which is DDD. And then 9th number is E, again it is reporting to C, reporting to D, and then 11th number again it is reporting to E. Okay, now here the sequence is little bit confusing to you, right? How the sequence of the manager association is not there in the right order. So how can you achieve it? You can give it a manager ID, okay, and then run it. So you will understand that how. So here, as you see, like the sequence is there in the manager order. When the first one is coming, then the second, then the third, and then the fourth. But if you want to order it by the employee ID, then how will you add it? How will you sequence? How will you order it? Like this, or just say EMP ID. Yeah. So 1 3 5 7 9 11. So according to the sequence of an employee ID, the manager IDs are listed now. But now you see like the orders of the manager IDs are changed a bit, right? So based on the employee ID, you may now see that who is manager of whom, right? If you want to do the reverse, then you just need to change this column on the order by and say like manager ID, right? And then you will see the order in a manager ID sequence. This is 1 5 7 9, right, like that. So this is like less number of records than 100. So in that case, it has considered it without any recursion. But say like if it is going beyond the limit of 100, in that case you might have to use the precise keyword with an option called max recursion, and then give it a keyword and give the range, the end range, okay, so that it will stop by that. Now this is another example I am using to help you understand how the max recursion can be used, option can be used. Okay, so let us say we are taking up 2 dates. One date is our start date, let's say 2025, the July 1st. Okay, the 1st of July 2025 we are considering as a start date, and then the second date is like our end date, which is 2025 the October 9th. Okay, so in that case the end date is what this, and the first primary date is this. So we want to return the result. In the case of we want to create the calendar dates and the result, and in the result what we want to return is like the current dates starting from the this date till this date. Okay, so let us just return that. See, it has created 101 records starting from the 1st of the July till 9th of October, right? That is what our request was, right? So it has considered that many things. Carefully watch here. It has written 101 records, but the recursion has happened for how many times? 100 times only. So one more is there in the result, but the less number of recursion you may have applied. Why? Because this condition is there. What this condition says is current date is less than at the rate variable end date. End date is what? This date. We want to go up to less than one date to that. To achieve this, what we have done here is we have used the start date as our initial factor and applied the union all onto it. Then we use the select statement. Then we use the date add function. Date add function will do what? It will add one day or as many days you mention it here in the second argument, and then you use the column name to which you want to do the increment it to. Means you want the date to be added. Say like the current date, whatever it may be, let's say just consider as a first date. The 1st of July is there. Now in the case of 1st of July, what it will do? It will add one day to it. Means it will become 2. From 1 it will become 2. And then 2nd of July will be listed down here as a current date in the result set. That is what we are seeing here, right? This is how. So it will keep on incrementing one day to it. Okay, one day it will keep on incrementing one by one. Okay, now it will go up to the last date, whichever is mentioned here, but we wanted to go up to the less than one. So it will eventually add one more day to it, meaning it will return this date well in advance before this end date itself. For that reason, we are giving it like a less than sign here. Okay, so the current date, whenever it will be less than this date, then stop it. Okay, so that is how our recursion works. Hope I made the concept clear here. And the other kind of important thing you need to understand is, the important thing to remember is like whenever you use the CTE, you need to use this as keyword as per the construct. Give any name any name of your interest, you can put it here. Then in the parentheses, not necessarily, not mandatory, but suggested or recommended. If you use it, it makes sense. It will help you understand what are the columns coming out of that CTE. Okay, now here maybe I gave it a name called ID, ename, manager ID, whatever name I wanted to give it, I gave it. I applied the union all. Union all, always remember the first column, whatever the first select statement, whatever the column names which has been given, whatever the type it has been given, the same type has to be there in the following union all operation, and it will always follow the same naming convention whatever it may have in the first select. Okay, so say like in the first we applied these column names, but we do not want to display this name and we want to give it some different names in the output. So we can give it like a different name for better understandability for the external users. Okay, so that is where this parenthesis and this column names will come in the picture. Otherwise you can just omit entirely, not a required one. Then if there is multiple and always consider, say like whenever you use a common table expression, always make it a habit like if there are any prior statements, then your with statement or say like your city table, right, or city expression, common table expression, whenever you use it, if there are any single statement prior to that, then always make it a habit using the semicolon before with statement. And then you can separate as many cities you want let's say like the similar city with some additional columns you may want in the output, then you can use it like this. Okay, just change the name to it, maybe city, just say date maybe. Okay, give it like a name, this kind of name, maybe just say date here, or say output date. Maybe I have used the same, say like I want to use the calendar date calendar entirely. Say I do not want this much complicated thing in this. Instead I just want to use this as a prompt clause. I will use it here, and select star from this city, whatever there may be as a date. I want to use like this city and use it like this. Okay, so here the column name would be the output date, right? Right, because output date is the output column that I have given the name here, because there is only one column, current date. Okay, current date. Okay, but we do not want to give it an output, we want to give it like a output date as a name, so that is why it is giving you this way. Okay, now it will also work the same way how it is working for the previous one. See, the same number of results are there. Okay, so as you saw that how this CTEs can be used, right? Now let us just move on to the subquery, the last topic for the day. So the subqueries, how we can create the subqueries is we will just create the temporary table, the table employee, and then the table department. I'll just create the tables with sample values, and I'll show you one by one the types of the subquery, how it can be achieved. Okay, now say like the first type of subquery, how we can achieve it using the comparison operators. How it can be written is select star from so and so table where that column name is equal to the comparison operator you may use here, right? Instead of using equal to, you may use it like not equal to, greater than, less than, whichever, like less than or equal to, greater than, equal to, anything you can use. According to that, it will perform result based on this operator, the comparison operator that you may use. Okay, so here we are using just like a equal to operator. So what may happen is, we'll see, what we want in the output is we want the department name called IT. We want only the IT department specific employees listing in the output is what we want. So how can we achieve it? We can use it using the subquery. That is one of the way. Okay, so it has retrieved all the records from the result. Let us just see, for the sake of understanding, how many records are there in this employee table. So see, like how many records are there, and there are 3 departments, 1, 2 and 3. Okay, now how many departments like are there? 3. So we just see that how many department: IT, sales and accounting. The first one is IT, second is sales, and third one is accounting. So now let us go back again to see this one. See, like 1, 2, 3, all of these are a different department thing. Now out of those we want only the first department in the result set, and that is why we return we have written this query like this. So it is returning only the department ID 1, which is IT employees only it has written in the result. That is how, if you want to use. Now there is an alternative way always. Okay, so if there is a subquery you may have written, right? If that subquery may be sometimes becoming more complicated, uneasy to be understood, right? Number of nested queries you might write one after the other, then queries may be performed perfectly fine, but still for the understanding purpose, or maybe from the performance wise, sometimes, right, you may need some fine tuning. So in that case it is always suggested you can use the joins. In that case, how you can achieve the same functionality is just applying the join onto the same table which is there in your subquery. Apply join with your employee table and department table. Apply join between those two tables on a particular column, whichever column you are using in the comparison operator. Here you are using the employee department ID, so then employee department ID here, and then the department ID which is here. Both of these columns are joined, right? And then you put the where clause as is, however it was here in this case. The same way you will use the where clause here, and then it will show you the same result, no difference. See, so this is kind of an alternative way. SQL number of experts may have show, and number of experts may write these queries in a different way. So we just need to know the wisest and the best option that you could write the query to. So maybe I'm giving you this option, maybe some other people might give you the other option in the case, but depends, right? So how you want to achieve it. So as and when the need comes, you can change between these two. Okay, whether you want to use the subquery, you can use subquery, or you may use the this one, the joins instead of that. Okay, so just use it according to that. Then the second type of subquery is place of an expression. Okay, it can be used in a place of an expression, meaning say like I have three columns, employee ID, employee name, and department ID coming up into the output. What I want in an addition to that one is, say I wanted an additional column called department name. Now as you saw that in the earlier case, when there is no join applied onto the department table, we may not be able to pull the department name in the select list, right? Because there is no way here in this construct that can provide you the department name, right? Because you are just fetching only one column out of the department table, applying a subquery onto it, and then just display the department ID only, right? Now in case you want to use the department name, then you may have to come to the second type of the subquery, which is a placing of an expression, meaning it can be used in the form of an expression. The same thing what you may have applied in the join up here, or say like condition up here in the where clause, the same kind of condition you may have to apply over here in the select list as a column. How you will write is, select say department, you want to get the department name out of the table department. We have the columns available with us to do the join or say like filtering of the records, right? So what we will do, we will fetch the table employee, give it an alias as E. Now from that employee department ID and D for department ID, right? Both of this column we will use to filter down the records, and for all of those matching department IDs, what we want to achieve is we want to fetch the department name for that. So for each of the department ID, we are going to fetch the department name alongside with these three columns, right? And then give it an alias called department name. So it will give you the department name to that. Simple, right? So first is the department name. Department name is IT. Second is the sales, and then the third one is the accounting. Now you understood, right? So the same way here in the case of join, it could be very easy. See here in this query you could not achieve that functionality, but still if we were at this stage, we have used the joins, we could have directly added the D dot department name, right? Simply it will just show you the same result what we expected out of it, right? Same result, only just that filter is applied here. If you just exclude this filter, it will bring you the all of the results, all of the records in the result, right? Same, right? No change required in the join. So join will help you in that way. So I'm just removing for the sake of clarity. Okay, now The same kind of join I am giving you here for an example so that you understand and how you can relate it with the previous query and the new query in the form of join. Use the same subquery here in the select list as a place of an expression, whereas alternative is the join just by adding a additional column to it. No difference. Now there is a third type. Instead of using both of these previous options, you may use the any, some or all as a keyword in combination of comparison operators. How you could achieve it? First of all, let us just understand. Write like a select statement, then put like a where condition, e dot department id, put like a comparison operator called greater than, and then say any as a keyword. Excuse me. So any as a keyword. Now the second statement in the subquery is select d dot department id from department d. So the table department from which, what we are saying here is wherever there is an department id matching to the employee department id, if there is any department id which matches with the department id in the employee table, then bring me all of those department id in the result. Means if there is a department id greater than the employee department id, say like there is a department id called 1, and say there are 3 departments in the department table. Now what may happen is, what we are expecting is, we want to result, we want the result like the department id greater than the one which our employee department id is. Suppose our employee department id is say 1, so greater than 1, whatever there may be department ids, only those records we want to get it in the result. Then 2 and 3 are the departments, right? Total 3 departments, 1, 2 and 3. Out of 3, say like we pick the first record from the employee table and it has the department id as 1. Now what we are saying it, we want the department id greater than the one which our employee id is. Then what it will be? 2 and 3. So 2 and 3 will be in the result here. See? So from the same table, from the employee table, we will find only 2 record or whatever records which may have the greater than first record of the department id of the employee table. Okay. So that is how it will be used. Then the same way the sum keyword can also be used. The same result set will come. No difference. Any or sum. Any means what? Any means at least 1. Sum means what? At least 1. Okay. Consider that way. Now all means what? Everything. Everything has to be matching. Now in case of a department id 1, say like I have used the department id 1 here. Now 1 greater than all, will that be true for all the case? No, right? 1 is not greater than everything in the department table. 1 can be greater than 1, 1 can be greater than 2, not possible. 1 can be greater than 3, not possible. So what will it return in the result set? Let us just run to see that. Nothing, because there is nothing in the department table which is greater than the employee department id 1. Now in the case of all, how will we approach is like select star from this employee where the department id greater than or equal to all. How all will perform is, let's say 1 is greater than 1, 2 and 3 department id. 1 is greater than or equal to all of the departments, no or yes, right? It is no. 2, the second department is greater than all the departments, no, right? Then the 3 is greater than or equal to all of the department ids, yes, because 3 is greater than 1, 3 is greater than 2 and 3 is greater than or equal to 3. For that reason only the third record will be result coming in the result here. See, that is how all works. Alright, so we have seen like any, some and all all three combination. Now let us move on to the type 4, where the using the correlated subqueries. How subqueries can be used? Correlated subqueries. There are 4 ways: in, not in, exist, and not exist. So we'll see one by one. The first one is like the select star from a table, where department ID in department ID, I mean like select department ID from so and so table, department table. So what we are doing, basically writing like this, okay, in a short. Suppose say you have the static values, you may write like this, okay. But say like in case you may have 1000 records. How will you list them down here in the in clause, right? So to narrow that down, we will use the tables instead of using the static values. That is how the in operator works. What it does is, it is treated as if like one, it is treated as if like, you know, this one or e dot department ID equal to 2 or e dot department ID equal to 3, like that it works internally, okay. But say like this much longer statement you would avoid to write in a practical scenario. So to minimize that, there is an option to write it in a shorter way, is this in clause. Use it like 1, 2 and 3 if you have the static values. If you do not have the static values and you have like a huge list to be used, then use it like a temporary table, and then or maybe physical table, whichever it could be. So use that table in the select I mean in the after the in clause, put it like a subquery here, and then use it completely and run it. So it will bring you all the records in the result set, okay. Now the same case, but the difference is it checks here it is checking for each of the records existence, whereas here it will just check the first occurrence of one record matching to the criteria, matching to the where clause. So the key that the column that we kept it outside here in the in clause, in operator, the same way we can use it here, but here it is used in the form of where clause, e dot department ID and d dot department ID, and keyword we have written is exist. Exist will be like a true or false, like a boolean statement. What it will check? It will check whether there is a department matching to the employee department ID or not. If there is a single record matching to this criteria, right, if there is a single, at least one record matching to this, then this statement will be executed and returned with the given condition, okay. So let us just run and see same number of records, right, because all of them are available here. Whatever the employee ID, employee department ID that we see, the same department IDs are present. But suppose if there is there is a department ID for some reason, maybe by fault or maybe by dummy data or whatever. So in that case, if there is a department ID which is not present in our department table, then it may not return that record in the result, okay. Now we will move on to the third type, which is like a not in. Now here is the case. I'm just reversing the table orders here just to show you. Let's say we may have department related records into the employee table for 1, 2 and 3. There are 3 departments currently. Suppose say like until yesterday there were 3 departments. 1, 2. First one is the IT, second is sales, and third is accounting. Now let's say today we introduce the 4th department. Maybe say like what we say, like maybe we can give it like marketing, maybe, okay. Say marketing we introduced today. Now marketing is the fourth department that we introduced. Now let's say if that 4th department is added into that table, and we want that we want to check that if that department is not in the employee table or what, only just return the department IDs, which are not there in the table employee. So let's say currently in our table we have only 3 departments, then it will not return you any results. But if say like there is any single record which is an additional record, or say like for there is no match, if there is a no match to this department ID into the table employee, then only those records will be returned. But here in our case currently there is nothing like that, so it may not return anything. We want to return something, then we need to add one record to the department table. Let us just add it and then see. In the department table, right, we want to insert one more record to it. We'll just insert 4th record, give it a name called marketing. Okay. Just added the record, and now we will run our statement. We will find one record, right, as marketing, because what we are saying is like if that department is not there present in the employee, means it is not being used by the employee table, return me only those departments, meaning like there is no employee associated to that department. We want to hire some employee, right? So in that case we may use this kind of query where not in will be used. Okay, now the same kind of functionality but with a different approach, or the different keyword which is like a not exist. In that case we may write like the same statements, but just move this where clause, or say like this condition, from outside to the inner condition called where clause here in the bracket, and replace this in keyword with the exist keyword. Same statement, same results, no difference. Okay, this is how not exist. But most of the cases, in the case of wherever there is a performance required, performance improvement required, in that case we usually use this exist option, the second option that we have mentioned here, and then there is a 4th option. These two are the option which are used alternatively in case wherever you use this in as a keyword or you use as a not in. When you use in, alternative to that is exist. Whenever you use not in, you would use not exist. Okay, that's it for the day. Thank you very much.